Hello everyone, welcome to my channel. In this video, we are going to discuss some interview questions in data structures that are generally asked by many companies and their answers are also provided. What is a stack? How does it follow the last in first out principle? Stack is a linear data structure that follows the LIFO principle, meaning that the last element added to the stack is the first one to be removed. It supports two main operations: push to add element to the top and pop, removing the top element. Let me elaborate more on stack. Stacks are commonly used in various computer applications and algorithms due to their simplicity and useful properties. Some common use cases of stacks include function call stack, expression evaluation, backtracking, and parsing and syntax checking. Function call stack. In programming, the function call stack is used to keep track of the sequence of function calls, allowing for returning to the previous function after completing the current one. Expression evaluation. Stacks can be used to evaluate expressions, including arithmetic expressions or converting infix expression to postfix expressions. Backtracking. In algorithms like depth first search, a stack can be used to keep track of visited nodes and backtrack when needed. Parsing and syntax checking. Stacks are used to check the correctness of brackets, parentheses, and other syntactic elements in programming languages. What is the complexity? Time complexity for push and pop operations in a stack. The time complexity for both push and pop operations in a stack is order of 1. It's a constant time, as they involve inserting and removing elements at the top of the stack. Explain the concept of a queue and how it follows the first in first out principle. A queue is a linear data structure that follows the FIFO principle, first in first out, meaning that the first element added to the queue is the first one to be removed. It supports two main operations: NQ, that is adding an element to the back, and DQ, removing the front element. Some more details on queues. Queues are commonly used in various computer applications and algorithms where the order of data processing is critical and needs to follow a strict sequence. Some common use cases of queues include task scheduling, print spooling, breadth first search, waiting lines in simulation. Task scheduling. In operating systems, queues are used for scheduling tasks, processes, or threads. Print spooling. In printer management, queues are used to manage the order of the print jobs. Breadth first search. In graph algorithms, queues are used to implement breadth first search traversal. Waiting lines in simulation. Queues can represent waiting lines in simulation applications. It is important to note that there are variations of queues, such as priority queues, which prioritize elements based on certain criteria, and double ended queues, which allow NQ and DQ operations from both ends. However, the core concept of a queue remains the same. Elements are processed in the order they are added following the FIFO principle. What is the time complexity for NQ and DQ operations in a queue? The time complexity for both NQ and DQ operations in a queue is order of 1, assuming an efficiently implemented, like linked list based queue. I just elaborate more on this queue. The two common data structures for implementing a queue are arrays and linked list, and each has its own time complexity for these operations. For an array based queue, the NQ operations has a time complexity of order of 1, while the DQ operation has a time complexity of order of n. On the other hand, for a linked list based queue, both NQ and DQ operations have a time complexity of order of 1, making linked list implementations more suitable for scenarios where frequent NQ and DQ operations are performed. What is a binary tree? A binary tree is a hierarchical data structure where each node has at most two children, commonly referred to as left child and the right child. Binary trees have a variety of applications and they form the foundation of many essential data structures and algorithms, such as binary search trees, AVL trees, heap trees, expression trees, and more. They enable efficient searching, sorting, and insertion operations, and they are commonly used to represent hierarchical relationships in data. It is important to note that binary trees can take various forms such as full binary trees, complete binary trees, balanced binary trees, and more based on specific rules and properties they adhere to. Each type of a binary tree has its advantage and use cases depending on the application's requirements. Explain the concept of a binary search tree. A binary search tree is a binary tree with the additional property that the left subtree of a node contains only nodes with values less than the node's value, and the right subtree contains nodes with values greater than the node's value. Binary search tree enables efficient searching, insertion, and deletion operations. Binary search trees are commonly used for tasks such as searching, sorting, and organizing data efficiently. What is the time complexity of searching for a node in a balanced binary search tree? In a balanced binary search tree, the time complexity for searching is order of log n, where n is the number of nodes, since the tree ensures that the search space is halved at each level. Note that order of log n time complexity assumes that the tree is balanced. In an unbalanced BST, where the height becomes linear, that means h is equal to n. The time complexity for searching can degrade to order of n, making it less efficient. To maintain the efficiency of BST operations, various self-balancing BSTs, example AVL trees, red black trees are used to automatically rebalance the tree during insertions and deletions, ensuring a logarithmic height and order of log n time complexity for searching and other operations. So, in this video, we have just seen some of the questions that are frequently asked in data structures. This video is useful to you. Thank you for listening.